Okay. All right. All right. Good evening, all. And can anyone confirm whether I'm audible? Yes. Okay. Thank you. All right. All right. Thank you. Right. So last day we started dimensions and we finished up to some point of dimensions like deriving dimensions. We finished up to deriving dimensions, right? And today, as we planned, we will be starting dimensional analysis, and that will be the most advanced part here you have in the first unit, right? First unit is measurements. No, in measurements we have units and dimensions in the first part. So in that part, the most advanced part is going to be dimensional analysis. So today we will be starting dimension analysis, and today itself we will be finishing the full lesson dimensional analysis, right? So if you are there or not in the previous class, that doesn't matter. After today, right, by the end of today's class, you will get to know everything that you need to know about dimensional analysis, right? So by the end of the class, we are going to finish dimensional analysis, right? Uh, okay. All right. It seems some of you are still joining in, but anyway, we'll start. We'll start. And from the last week, were there any homework questions given? I can remember there were few questions given by me. Yeah. Is it question number 6? Was it question number 6 in the drift? Question 6? Okay. Yes. How many questions we have discussed? How many questions we have discussed from question 6? Oh, none of the questions were discussed from 6. Yeah. How many questions we have discussed? Have we discussed any questions, any subparts on the question 6? Oh, none of the parts were discussed. None. All right. Okay. Okay. Uh, okay. Since there are few new students, I'll put the respective tute again, right, to the chat box in Zoom, so you can go there and download it, right? And if you are on YouTube also, you can get it from YouTube chat. I'll put there, right? Give me a minute. Give me a minute. Okay. So in case if there's anyone uh, who didn't get the route, you can take it from the chat here. Give me a second. Okay, if you are on YouTube live and if you didn't get the tute, what you can do is I will drop a message with the link there, so you can visit that link and download the tute. All right. Uh, so can you confirm whether you can see the tute in the chat box? Now it should be visible. Yeah, now you can see it now, right? All right. Okay. So before jumping into dimension analysis, there are a few questions from few questions I gave as homework from the last part we had, right? So I'll quickly discuss that, and we are going to go to dimension analysis, right? We are in question 6. Question 6. All right. So it says find dimensions of A, B, C, D below accordingly, right? For that, the respective theory part is this. The respective theory part is this. Listen, listen. The respective theory part is this. This is from what we discussed the last day, right? First thing, we discussed that if an equation is dimensionally correct, right? If an equation is correct or if an equation is dimensionally correct, dimension of left hand side of the equation is equal to that of the right hand side of the equation, right? Which means if an equation is dimensionally correct, dimensions of left hand side of the equation is equal to dimensions of right hand side of the equation is equal to dimensions of right hand side of the equation, RHS. Fine. That is one thing. That is one. And other than that, if there are two or more terms we are adding, right? We discussed about dimensional simplifications. If there are two or more terms we are adding, if they are dimensionally equal only, you can add or subtract, right? So subtraction is also a negative addition, no? Right? So if you are adding two or more than one physical quantities terms, they should be dimensionally equal, dimensionally same in order to add or subtract, right? Second point is this. Second point is dimensionally equal terms can be added though, subtracted, right? Dimensionally equal terms, right? So other than that, we discussed 5 dimensionless scenarios, right? And they are very much useful when it comes to identifying dimensions of unknown physical quantities. There are 5 dimensionless occasions, and other than that, dimensionless occasions. There were 5. There were 5 dimensionless occasions. 1, 2, 3, 4, 5. So I'm quickly recalling the theory. First one is numbers. First dimensionless scenario, numbers, right? Second dimensionless scenario, angles. third dimensional scenario, trigonometric ratios. Trigonometric ratios. Right? And 4 logarithms. Logarithms. And 5 indices. 5 indices. So based on this part, based on this area, we can determine dimensions of unknown physical quantities. Right? So that is what we are going to do under part 6. Okay, let's see. Go to question 1, question 6. Question 6 and this is subpart 1. Question 6, subpart 1. Right. Now, since you are registered for the class now, this month onwards, you will be getting the hard copy of this tute as well. Right. And when you are registering to the class, make sure that your correct address is entered there, because that will be the same address that we will be using to post your tutes. Right. First tute was only given as a soft copy because we started 2 weeks before, 2 weeks back. Right. Question 6, part 1. Question 6, part 1. Go to question 6, part 1. Let's see. Let's see. So I'll be using all of them to solve now. Right. Now we are in tute, page number 5. Page number 5. Right. Question 6. Right. Part 1. P equals, it says P equals F plus A over B minus C plus dt plus dt. And the introduction is given. P is pressure, F is force, T is time. And in the introduction, that T should be simple T, not capital T. That's a small typing error, typing mistake. Right? In all the introduction terms, it should be not capital T, it should be simple T, time. Okay. Now we need to find dimensions of A, B, C, D. Right? Look at here. We need to find dimensions of A, B, C, D. Now we have to use these things that we know about dimensions accordingly. Right? Now, as the first thing what we know is, this is an equation. Right? This is an equation. Since this is an equation, dimension of left hand side of the equation should be equal to dimension of right hand side of the equation. Right? See, dimension of left hand side should be equal to dimension of right hand side of the equation. And if we have added or subtracted terms, they should be dimensionally equal as well. Right? So therefore, dimensions of pressure at once I can say dimensions of pressure should be equal to the dimensions of this whole term. And it should be equal to dimensions of this term as well. Because since there is an equation, dimensions of left hand side is now the dimensions of pressure. The right hand side should also be the dimensions of pressure. But right hand side consists of two added terms as whole terms. This is a whole term, whole single term, and this is also a whole term. Then if there are two added terms, their dimensions should also be equal. Right? So which means at once I can say dimensions of pressure will be equal to this. First I am going to determine dt, d. Then dimensions of dt. Right? From this I am going to determine d. Dimensions of pressure, that is something known. Right? We have proved it. Dimensions of pressure is ml minus 1, T minus 2. Dimensions of pressure, ml minus 1, T minus 2. And dimensions of d times dimensions of T is capital T. Simplify this. So dimensions of d will be, take this T to the other side, ml minus 1, T minus 3. So one answer is here, ml minus 1, T minus 3. Right? And then I can say this F is added with A. We can add if they are dimensionally equal. So which means at once I can say dimensions of F equals dimensions of A. Dimensions of F equals dimensions of A. F is a force, right? Dimensions of force is ml t minus 2, that is proved, right? So which means A is here, dimensions of A is mlt minus 2. Dimensions of A is mlt minus 2. Dimensions of A, right? Now this is this term, this term also has dimensions of pressure and it consists of a ratio. Then which means that ratio should give us the dimension of pressure, right? And these two are subtracted, B and C. If B and C are subtracted, which means dimensions of B and C are same, right? Since B and C are subtracted, dimensions of B and C are same, right? So with that idea, I'm going to write this at once like this. Dimensions of pressure will be, now from this term, we know here you have dimensions of F plus A. Let me write the whole term first. F plus A over B minus C. This is equal. This is equal. Right? But dimension of F plus A is the dimension of force, no? Because a force can be added with another force only. So dimension of this whole term F plus A will be a force. Right? Which means dimensions of pressure can be written as this side is a dimension of force over, for sure we know dimensions of B and C are same. For sure we know dimensions of B and C are same because they are subtracted. They are subtracted. Therefore, dimensions of B and C are same. Right? They are same. So therefore, without writing both, I'm going to write just B. Right? Because if B is known, which means C is also known, B equals C. Right? Substitute these values. P is a pressure, ml minus 1, T minus 2, ml minus 1, T minus 2. And force is ml T minus 2 over dimensions of B. Right? See, m to m cancels, T minus 2 to T minus 2 cancels. Right? And cross multiply this, B will be L squared. B will be L squared. So if you don't see it here, I'll write again. B will be L squared. Right? Cross multiply this. B is L squared. Which means dimensions of B equals dimensions of C equals L squared. So you can check your answers. Dimensions of A, mlt minus 2. Dimensions of B and C both are L squared. And dimensions of D, ml minus 1, T minus 3. And if you got any doubts, any clarifications needed, you can quickly ask. I'll discuss few questions from here. Now students are joined. Now all the students are joined. So we are going to start dimension analysis. Yeah, all good. Is it clear? Is it clear, students? I'll be erasing this part. Yeah. So if that is clear, you can always engage with me, right? Now, if you are on Zoom, you can just write that is clear and put to the chat, or at least put a thumbs up. You have reactions on Zoom. So if you are on Zoom, you can easily put a reaction, right? And if you are on YouTube live, you can put that to the live chat, right? So at least a thumbs up if that is clear, right? So always have that interaction with me because you are in an online class, right? So when we are in online classes, we don't have eye contact. I don't see you physically and I don't know whether you actually work the proper way, right? So I'm delivering my best, but I don't see you physically now. So therefore, always try to interact with me. And if I ask something, some answers or something like that, always try to engage answering. Then I know whether you are on the track or not, right? Okay. Second death balloon. Second death balloon. It says F equals number 2. It says F equals simple 80 cube brackets 6 plus half BT squared. We discussed few questions in the class as well, and I gave these questions in the tute as an additional homework, right? Otherwise, we discussed few questions in the class, right? Force, F can a force, and T is time, and all of these T's has to be simple T, not capital T. Yeah, I told you to make that correction, right? I told you to make that correction, right? See now, this one 6 is a number. 6 is a number, right? Very special. Numbers are dimensionless. Numbers are dimensionless. So this is dimensionless. And if this 6 is added with this part, if that 6 is added with that part, dimensionless physical quantity can be added with another dimensionless physical quantity only, right? I told you, if we are adding 2 or more terms, adding more, subtracting 2 or more terms, they should be dimensionally same, right? If that is dimensionless, the other one should also be dimensionless, right? So this whole term is also dimensionless. This whole term is also dimensionless, right? So which means this entire bracket is also, this entire bracket, this one, this entire bracket is also dimensionless, right? Having that in mind, first I am going to calculate B. If you are dealing with dimensionless physical quantities, always we can consider dimensionless quantities as 1, right? I told you last day, always we can consider dimensionless quantities as 1, right? So let's take this one, which means dimension of half BT squared should be 1, because that is dimensionless. 1 means dimensionless. 1 means dimensionless, right? And from here also, we know half is dimensionless, right? Now, if you apply dimensions, this is what you can write. Dimension of half times dimensions of B times dimensions of T squared will be 1. And half is a number again. Half is a number. Half is a coefficient. Since there is a number, that is again 1, dimensionless. I need dimensions of B, and dimensions of T squared is capital T squared equals 1. Subject B from this, there is T minus 2. So dimensions of B is T minus 2. Now, since this whole bracket is dimensionless, right? Now, this is a product. See, this is a multiplication. 80 cube is multiplied with this bracket, but that bracket is dimensionless. For sure, we know that that entire bracket is dimensionless, right? So therefore, dimension of force should be equal to 80 cube, right? So therefore, dimensions of force should be equal to dimensions of 80 cube, right? So which means dimensions of force equals dimensions of A times dimensions of T cube, right? F is a force, that is MLT minus 2. I need A, and T cube is T cube, capital T cube. Simplify this. So dimensions of A will be, take this to the other side, it becomes minus 3. Then altogether, MLT minus 5. So these are the dimensions of A and B. Dimensions of A and B. You can check with your answers. So you can check with your answers whether it's correct. Number 3. Number 3. PV equals nRT plus A plus BT squared. Right. Number 3. PV equals nRT plus A plus BT squared. A plus BT squared. P is pressure, V is volume, and T is time. Right. Again, similar type. We have two unknown variables A and B, and these three. About these three, nRT, they are unknown. They are unknown, which means now since they are unknown, we have to eliminate them from our calculation, which means we can't consider them in our calculation. So you have to approach the question in such a way that you don't have any impact from nRT terms, right? So this is the argument I'm going to use. Dimensions of PV should be same to nRT and A and BT squared as well, because we know dimensions of left hand side of an equation is equal to the dimensions of right hand side of the equation, and if there are added or subtracted terms, addition or subtraction is only possible with dimensionally equal terms, right? So which means dimensions of PV should be same to dimensions of nRT to A to BT squared, right? So I can write this at once. Dimensions of PV equals dimensions of nRT equals dimensions of A equals dimensions of BT square, right? Now from this, first I'm going to take these two, right? First I'm going to take these two. So what I can say is dimensions of PV equals dimensions of A. P is a pressure. Dimensions of pressure again ml minus 1 T minus 2. And V is a volume. Dimensions of volume is L cube times A. Simplify this. L minus 1 to L cube is L squared, which means ml squared T minus 2. Right? So dimensions of A is here. That is ml squared T minus 2. ml squared T minus 2. And to get B, either you can equate these two or these two, any two, that doesn't matter, any two. I'll go like this. Dimensions of PV equals dimensions of PV again. Right now, since A is known, you can directly equate A and BT squared as well, since A is known. Right? Totally fine. B T squared. Right? Now again, dimensions of PV is here. Now if you simplify this, again you will get ml squared T minus 2. Right? And that equals dimensions of B times T squared is capital T squared. Right? Okay, then subject capital B, it is ml squared T minus 4. So dimensions of B is this. Right? Since nRT is not given, you can't use nRT in your calculation because that is not given. We don't know dimensions of them. Right? Yeah, I think that's enough from the homework questions. Yeah, that's enough from the homework questions. Now let's move on to our lesson today. Right? Let's move on to our lesson today. Okay. Any questions about these three before moving on? Or any other questions from what we have discussed the last day, students? Is there anything you need to clarify from my end? Is there anything you need to clarify from my end? Or is it all clear up to this point? Quickly. Is it all clear up to this point? Clear. Yes, good. Okay, others? Are you all good? Everyone? Yeah. What about the students on YouTube? Yeah. What about the students on YouTube? Is it clear? Now, if you also have any questions, feel free to put them to the YouTube live chat. I'll be looking at both chats. I'll be looking at both. Right? So I can see both chats. So therefore, if you have anything, doesn't matter whether you are on Zoom or YouTube today, right? Since it's a free seminar, it is streamed through YouTube as well, right? So doesn't matter where you are, you can always ask if there's anything. Okay, right. Yes. So from question number 3, 4th and 5th were given as homework. Yeah, that was dimensional verifications, no? Yeah, since we discussed like three-dimensional verification in the class, right? So I won't be discussing that again now, right? If you got any doubts when you do that questions, dimensional verifications, right? I gave you that homeworks, those homeworks as something additional to what we have done in the class, right? So if you got any doubts, you can contact me in a free time, right? So otherwise, I think that is okay because we discussed around, I think 3 or 4 dimensional verifications in the class. So therefore, that will be enough, right? So let's move on then. All good, right? Let's move on then. So as the next heading, write down. So this is the last part here in dimensions, the very last part in dimensions, and as I told you, this is the kind of advanced part, right? Advanced part in dimensions, right? Take down the heading as dimensional analysis. Take down the heading as dimensional analysis. Take down the heading as dimensional analysis. Dimensional analysis. Dimensional analysis. Okay, listen now. Listen. Right, listen. Okay. Now, most of you here don't have any idea about dimensional analysis, no? Right? Most of you don't have any idea about dimensional analysis. And if you were there in last 2 classes, and especially in the last class, so you know what dimensions are, and you have dealt with dimensions up to some extent. But yet, you don't know anything about dimensional analysis, right? So freshly, now we are going to start dimensional analysis, right? First listen, and by the end of this class, by the end of today, by the end of the class, right? By the end of these 3 hours, you will know everything about dimensional analysis. You will get to know everything about dimensional analysis, and we will practice few questions from dimensional analysis here in the class itself, and we are going to finish this off, right? So that's a plan. That's a plan. So be active in the class, be actively present in the class, and once the initial theory parts are discussed, then we will start few sums, right? Example questions. Then there you can do those questions actively, and we can finish this off successfully, right? Listen, when it comes to dimensional analysis, this is a technique. Dimensional analysis is a technique, and this technique is used to determine the correct relationship between terms of an equation, right? Listen again. Dimensional analysis is a technique, it's a tool, or it's a technique used to determine the correct relationship of terms in an equation using their indices, right? That is the whole idea here. So let's see how that is possible to do, how that is possible to do with dimensional analysis, starting from here, right? So dimensional analysis is a technique, that's a tool we have, right? We don't need to know any equations. Let's see how we do. We don't need to know any equations, right? Without knowing any equation, our ultimate goal, ultimate target of dimensional analysis is deriving the correct equation, right? මෙතන කරන්නේ මේ dimensions හොයන්න නෙමෙයි කලින් කරා වගේ. That is not to determine dimensions. This is not to identify dimensions, right? Here what we do is we are going to build up a whole new equation using dimensions, right? Newly we are going to build up the equation, right? අපි දන්නේ නැති equation එකක් අපි equation එකක් කියලා දන්නේ නැති නිකන් relationship එකක් තියෙනවා නම් if you just have a relationship among few terms, we can build up that relationship, we can build up that equation using dimensional analysis. That is what we are going to do here as the ultimate ultimate target of dimensional analysis, right? All right. First, write this down. Write this down. Dimensional analysis. Write down. Dimensional analysis. Dimensional analysis is a technique. Is a technique. Dimensional analysis is a technique. Is a technique / tool. Dimensional analysis is a technique / tool used to determine the correct relationship. Used to determine the correct relationship. Used to determine the correct relationship. Used to determine the correct relationship among terms to create an equation. To create an equation. To create an equation. To create an equation using indices. Using indices. You know indices, right? Using indices. Using indices. Using indices. Right. Right. So basic idea is this. Look at here. Look at here. So stop all your work. Stop all your work and look at here. Right. Now, if you grab these fundamentals, the fundamental concept behind dimensional analysis here, you can do any question from dimensional analysis without any kind of a hassle, right? That I can guarantee if you listen this carefully and if you grab this basic concept behind dimensional analysis properly, any question is doable, right? Okay. Your questions when it comes to dimensional analysis are going to be different from equation to equation only. The methods will be same, right? So therefore, if you understood this from the beginning, definitely you will tackle any question. That is for sure, right? Look at here. Look at here. Now, since we know dimensions of left-hand side of an equation, dimensions of left-hand side of an equation is equal to dimensions of right-hand side of an equation, right? Now, in a scenario where, let's say we have a relationship between dimensions in two sides, right? Look at here. Look at here. Let's say, here I have something like m to the power x and L to the power y and t to the power z. And on the other side, let's say you have the dimensions as, right, m to the power, let's say p and L to the power q and t to the power r, let's say. Now, having equal dimensions in both sides means, now if we have this kind of a equation with dimensions, this is an equation with dimensions now, then in order to satisfy this, now individually also the dimensions of m should be same in left hand side and right hand side now, right? If total dimension is equal, right? If the entire dimension is equal, if I break it down to MLT separately, then dimension of M should be same and dimensions of L should be same in either sides and T should be same in either sides. From that idea, I can say, now if the index of M on left hand side is X and if the index of M in right hand side is P, right? We can say to satisfy this, now it's a must to satisfy M, it's a must to be X equals P, X equals P. It's a must to be X equals P. It's a must, right? It's a must to be X equals P. Similarly, to satisfy that above condition in terms of L, Y should be equal to Q. And similarly, if I consider T, Z should be equals to R, right? So this is the idea we are going to carry forward here. This is the idea we are going to carry forward here, right? This is the idea we are going to take forward, carry forward here, right? Simply this is the idea. So you know, in any equation, left hand side dimension and right hand side dimensions are equal, right? And in the dimension, inside the dimension, we have a combination of MLT. No, you have a combination of MLT. Mokkari M terms ටිකක් තියෙනවා, M dimension එකක් තියෙනවා, L එකක් තියෙනවා, T එකක් තියෙනවා. In right hand side also same, right? Then having equal dimensions means, now if I consider M and L and T separately also, there should be same separately, individually, right? So therefore, if I consider M, X should be equal to P. If I consider L, Y should be equal to Q. And if I consider T, Z should be equal to R. This is the idea we are going to take forward in dimensional analysis, right? Tell me whether it's understood, right? තාම අපි dimensional analysis කිසිම දෙයක් discuss කරේ නැහැ. මම මේ idea එකක් විතරයි දුන්නේ. This is just an idea about what concept we are going to use in dimensional analysis. Tell me whether it's clear quickly. මේ thumbs up එකක් හරි දාන්න at least. Yes. All good? Yes, good. Okay. Right. Okay. Okay. Write down below. If an equation is correct, write down below. If an equation is correct, if an equation is correct, dimensions of left hand side we call LHS, left hand side. Dimensions of left hand side should be equal to dimensions of right hand side. Should be equal to dimensions of right hand side. Okay, now take this down, starting from here, take this down up to this point. Take it down up to here, starting from here. Starting from here, take it down. And students, listen. Now, if there are anyone who didn't join the class yet and who wish to join the class, convey the message that next week we are starting measuring instruments, right? One of the main parts, one of the major impactful parts in Unit 1, and actually the most impactful part in Unit 1, right? Measuring instruments. So we are starting measuring instruments next day, and I'll be sharing all updates, all the flyers, updates and everything in my channels and groups. So make sure you are in the channels and groups so you can get all updates. And if there are anyone who haven't joined the class yet and who is willing to join to the class, so you can share that message among your friends as well. right, friends and colleagues, that we are starting measuring instruments next week. And for all instruments, I'll be using the actual real physical instrument to you to demonstrate, right? Now, as an example, now first day we are starting with vernier caliper. We have four instruments: vernier caliper, micrometer, screw gauge, a sperometer, traveling microscope. So we are starting off with vernier caliper. Now, when I explain about vernier caliper, I'll be showing you the actual instrument for the demonstration. Right? I'll be showing you the actual instrument for vernier caliper, micrometer, screw gauge, and others as well. Right? Not just graphics. Right? I'll be showing you how the actual instrument works. Right? So keep that in mind. We are starting measuring instruments next week, and by the end of this month, measuring instruments will be finished. Right? All four measuring instruments will be finished by the end of this month. Right? So don't miss any classes after measuring instruments, because they are very much impactful parts coming up. Very much impactful parts. In terms of marks you can attend, I'm explaining in terms of marks you can get. Right? Very much impactful. Okay, finished? Right. Now, shall we try few examples? Let's say, see, now this is an example. Look at here. Look at here. Let's say we have something like this. Look at the board. Now, you have an equation, dimensional equation here like this. Let's say m squared L minus 1 T squared, and from the other side you have got, right, m to the power x, L to the power, let's say, x plus y, and let's say t to the power z, t to the power z. Now in such a scenario, now what we can do is we can do something and determine x, y, z, right? Now if these indices were unknown, if they are unknown variables, now we can use this argument and simplify x, y, z, and we can get x, y, z, right? මේ example එකත් කළා example dimension analysis එකක් කළා පෙන්නන්න. Right? See, now in this scenario, if you need to solve this, you can take this down and solve with me. See, if you need to solve this, now first I can consider m. If I consider m, dimensions of m in left hand side is 2, and on right hand side is x. So which means x equals 2. X equals 2. Right? And if I consider L, dimensions of L in left hand side is minus 1. Minus 1. In right hand side is x plus y. Right? Dimension එක same වෙන්න නම් කෙලින්ම index එක same වෙන්න ඕනේ. The argument is that, right? If dimension of L is same in both sides, its index has to be same. Right? That's the idea. That's the whole idea. Then minus 1 equals x is known 2 plus y. So which means y equals minus 3. Y equals minus 3. And if I need t, dimension of t in left hand side is 2, in right hand side is z. So which means z is also 2. So likewise, now when we have unknown indices, we can determine their values like this, right? Take this down as an example. Take this down as an example. Take it down. Finished? Okay, to practice this further, listen, to practice this further, I have given you few questions in the tute as well, right? To practice this further, there are a few questions given in page number 4, question number 4. Go to page number 4. Go to page number 4. Tute page 4. Question 4. Right? There I have given 3 equations to practice these simplifications. Right? So let's practice few and move on. Go to first one. Go to first one and start the first one. Start the first one. And there are 2 typing mistakes here. First, listen. There are 2 typing mistakes here. In the first one, the equation should be ml squared t minus ml minus 2 t minus 2. This is how the equation should be, ml minus 2 t minus 2 equals right hand side m to the power x, m to the power x, L to the power x plus y. It should be L to the power x plus y, yeah, not g, x plus y. Please make that correction. And t to the power 2x minus y plus c. 2x minus y plus c. Okay. Okay, this is the given question. This is the given question. So start working on this and determine x, y, z. Determine x, y, z. And the second typo is in the second question. Now, if you finish the first one, you can start the second one. In the second one, the typing mistake is in right hand side, the index of t should be t to the power x minus 2y plus z. It should be x minus 2y plus z. Right. So in case if you started the second one, okay. Let's start the first one and tell me x, y, z. All right, Balu. Tell me x, y, z before I start. I'll be also starting in 2 minutes. I'll also be starting in 2 minutes. Right? මේකමයි කරන්න තියෙන්නේ. මේ විදිහට equations simplify කරලා මෙරිය determine කරන්න. Determine xyz. Determine xyz and tell me. Now this step is actually an intermediate step which is coming in dimension analysis. So before starting a full dimension analysis, so I'm giving you these questions to try out the simplification, to practice the simplification, right? අපි බලමු මේ equation එක එන්නේ කොහොමද කියලා. This is coming from dimension analysis and this is actually an intermediate step of our dimension analysis, right? ඒකට තමයි මේ practice කරන්නේ. Right, determine x, y, z and tell me. And meanwhile, if you got any questions, feel free to ask anything. If you need to know anything, no need to wait, just feel free to ask anything, right? Feel free to ask anything. Any answers for XYZ? Anyone? Okay, so I can see a few answers. X equals 1, y equals minus 3, z equals minus 7. One says that so do we take m as 1? Yeah. Why? Now, if there is nothing in the index, which means there is 1. So let's say we have x. X means x to the power 1. So by default, we don't write 1. We don't write 1. Yeah, you are correct. Now, if we say 2, actually 2 is 2 to the power 1. Actually 2 is 2 to the power 1. So likewise, with an m again, that is actually m to the power 1. Na? M means m to the power 1. M is m to the power 1. So if there is nothing there, which means power 1. X equals 1, y equals minus 3, z equals minus 7. Same set. Same set. Okay. Okay, you are getting answers. Good. I'll also start. Good. Say first m. If you consider m in this side 1, right side, that is only x, which means x equals 1. Right? And then since x is known, we can go to L minus 2 equals, there is no order here. MLT kila order. If you are doing T first, that is all up to you. That is fine. Minus 2 and here x plus y, which means minus 2 equals x is 1, 1 plus 1, 1 plus y. Y equals minus 3. And then you can go to T. Left hand side I have minus 2, right hand side 2x minus y plus z. And minus 2 equals 2x. X was 1. Then 2x kill again 2. Minus y. Minus y. Y is minus 3. Correct? Minus y. Y is minus 3. Plus c. So minus 2 equals 2 minus minus 3 means make a plus, then 5 plus z. Yeah, you are correct. Z is minus 7. These are the values. You are correct. Good. Yeah, go to the row number 2. Second one. Under question 4. Second one under question 4. And they are in T, that is not 2. That should be Z. Small typing errors. Let me write it on the board again. LT minus 2 equals number 2. Number 2. LT minus 2 equals M Z plus Y. M Z plus Y. LX. L to the power X. And T to the power X minus 2y plus Z. X minus 2y plus Z. Not 2 plus Z here. Plus Z. Right? 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 Second one. That also I will start in 2 minutes. So please engage. If you got any answers, you can put them to the chat box. Then I can see and I know whether you are on the track and whether you have understood what I say. Right? Because in an online class, that is very much needed. Because I should have the understanding whether you have understood what I'm discussing here. So that's why I'm always asking you questions to make you engage with the session. Right. Yeah. Any answers for question 2? Okay, good. Try it. Try it. Right. Now, this is to practice this simplification. What you are doing in dimension analysis. When you grab these things from the very beginning from here, right? Uh, the rest of the dimension analysis is going to be very easy, right? So step by step, when you grab everything from here, that is going to be very much easier, very easy. Okay, any answers? Any answers? When you register for this month means month of August also, use that form that I have put to the group, right? And next month onwards, you can use the website and do all the enrollments, right? මේ month එකට විතරක් form එක use කරලා register වෙන්න, right? මම form එකක් දාලා තියෙයි, registration form එකක් දාලා තියෙයි. ඒ form එක fill කරලා මේ month එකට විතරක් register වෙන්න. Next month onwards, next month is September onwards, you can do everything on the website itself, right? Website එකම කරන්න පුළුවන්. Website කියන්නේ LMS එක and the website. Accessing recordings, enrolling to classes, receipt uploads, payment approvals, everything will be done from the website, right? September ඉඳන් මේක launch වෙනවා. That will be launched in September, right? So only for this month, stick to that form that I have put, and next month onwards, everything will be streamlined through the website. Yeah, x equals 1, y equals 5 over 2. So I received one set of answers as, and z is also here. There are three terms, x, y and z. මේක z මම මේක correct කරගන්න කියලා කිව්වා. correct කරගත්තේ නැත්නම් මේක 2 කියලා අරගෙන දන්නේ නැහැ. Right? This has to be z. This is z. Please correct this because this was a typing error, typing mistake in the tube. Please correct it. That is z. Right? And there should be 3 answers for x, y, z. There should be 3 answers for x, y, z. Any other answers? Any other answers? Okay, listen now, since you are new to the subject here, now for the class also, this is actually the 3rd day of the class is ongoing, and you have started your A-level journey fresh. You have started your A-level journey fresh after O-level results, right? So therefore, now from here onwards, from this period of time onwards, work with a plan, work according to a plan, right? So in first 2 classes also I told you the same. Now have a time allocation. Have a time in sense, have a time allocation for your subjects in a weekly basis. Now as an example, you have to have a rough timetable about divided among all 3 subjects in a weekly basis, right? Then that will be very easy to move on, right? Now in this stage of your journey, So at least try to allocate 1 hour. At least try to allocate 1 hour for subject, and we have to increase it when we are moving higher up in the ladder, right? දැනට 1 hour වගේ subject එකකට allocate කරලා පොඩි time table එකක් rough එකක් හදාගන්න. ඒතකොට ඔයාලට ඒකත් එක්ක work කරන්න පුළුවන්. Now, as an example, let's say physics. Now in your timetable, say you are doing physics on Mondays, 1 hour on Monday and Thursday and Saturday. අන්නේ දවස් තුනේ ඒතකොට physics කරනවා. And it should be done weekly. And I'm not talking about the class times. That 1 hour is for your own studies. Maybe you are going through what you have discussed in the class in the last week again, and sometimes you are practicing some homework questions given, practicing some questions in the tute, and sometimes maybe you are trying to do some past papers. Now, I didn't allocate you to any past papers yet. Now, if I'm allocated due to past papers, it might be you are trying some past papers, right? So likewise, allocate that 1 hour for your own studies, right? So as you have that for physics, you have to have it for other 2 subjects as well, right? So from here onwards, make that a habit, and continue doing it, right? So therefore, if you do it properly in this A-level journey of 2.5 years, definitely you will go through. Because the idea is, when it comes to A-levels, you can't just work at like last 3 months or last 2 months, last month and go through. That is how A-levels are, right? එහෙම තමයි A-level subjects වල තියෙන gravity එක, right? Science stream එකේ මොන subject එක කරත්, science stream එකේ bioscience or maths or ICD with ICD or whatever it is, right? For any science stream subject, that scenario is same, that story is same. Therefore, make that a habit, right? අන්තිමට ගිහිල්ලා එකපාරට වැඩ කරන්න ගන්න බෑ. As an example, the 25 batch, that they have 12 weeks ahead of the exam now, right? This is actually the 12th week before the exam. Now, there are students who work around 18 hours a day, right? They are real numbers. These are real numbers. They are working around 18 hours a day, right? Classes මොකුත් නැති දවස් තියෙනවා නම් 18 hours වැඩ කරන ළමයි ඉන්නවා, right? So they are working 18 hours a day. මේ numbers achieve කරන ළමයි ඉන්නවා, right? And usually the average usual duration is like 15-16 hours, but 18 hours වැඩ කරන අයත් ඉන්නවා. There are students who work up to 18 hours as well. So ඒ practice එක මුලින්ම තිබ්බේ නැත්නම් we can't increase that to 18 hours, 15 hours later on, right? So therefore, now at this stage of your journey, as I told you, 1 hour is enough. 1 hour is enough. 1 hour allocate කරගෙන ඔය practice එක ගන්න. Make this a practice, right? And when we move on, I'll tell you how do you need to increase that working time, right? So I have that idea. මම අලුත් අය තින්න නිසා කිව්වේ ඉතින් එහෙම පොඩි time table එකක් තියාගන්න, right? That is very much needed, right? Term test target කරලා එහෙම පාඩම් කරන්න එහෙම එතකොට ඕනේ නැහැ. Because if you have done everything properly, perfectly from the beginning, right? Term tests are nothing, because if you have done everything, if you have completed everything when you are going to face the first term, right? So without doing any other special thing also, you can sit the term test and go through. Term test එක target කරලා වැඩ කරන්න බෑ. We have to work targeting the A-level exam, and term test will be there in between, right? Okay. So I didn't receive any answers. So what happened? I thought you are still doing. What happened? No any answers for this one? Students? No any answers? Why? What happened? Yeah, I'm going to start. Any answers? No? Let's see. Let's see. Okay, first I'm going to consider m. Tell me, if there's no m term, listen. If there's no m term in left hand side, now you can see there is no m in left hand side, which means what should be index of m? Think and tell me. If there is no m term in left hand side, what should be the index of m in left hand side? What should be the index of m in left hand side? 1, 0, 1. See. Man කලින් ඒත් මේක පොඩ්ඩක් explain කරා. X to the power 1 is x. X to the power 1 is x. X to the power 0 is 1. Zeroth power of any number is 1. Zeroth power of any number is 1. Right? 2 to the power 1 is 2. But 2 to the power 0 is 1. 10 to the power 0 is also 1. 100 to the power 0 is also 1. Zeroth power of any number is 1. Zeroth power of any number is 1. Now, if there is no m here, which means there is 1. 1 කියලා කියන්නේ index should be 0. Right? මේ value එක 1. This is like 1 times LT minus 2. So, value of index of m should be 0. This is the idea. So, I know all of you know this from O levels. Right? මේ idea එක මම use කරනවා. So, which means m at this side is, right? M at this side is, this is actually m to the power 0. This is actually m to the power 0. Not given that we need to know. This is actually m to the power 0. Not given. You have to know m to the power 0, right? Okay, let's see. Now first, I'll be doing first doing L is easier because for L only x is here. First I'll do L. See, L. Then from left hand side, I have 1. L is 1. L is 1. ML again, L is 1. Right hand side x. So which means x equals 1. Now I will be doing m. Now I will be doing m. Now if I consider m, in left hand side there is 0. Right hand side, z plus y. Right hand side, z plus y. Right? Which means z equals minus y. No? I will consider this as equation 1. I will consider this as equation 1 because now I can't get any answer for z or y because both are unknown. And then I'm going to think of the other one remaining, that is t. Right? Final answer ka kinna. Then go to t. Consider t. In left hand side I have minus 2. Right hand side x minus 2y plus z. X is known, x is 1. Then minus 2 equals 1 minus 2y plus z. Simplify this. I can take this 1 to the other side, then it becomes minus 3. Minus 3 equals minus 2y plus z. Right. So this is my equation 2. Right. Now this is something you know. Now you have 2 unknown variables and 2 equations, which means definitely it is simplifiable. For sure it is simplifiable as simultaneous equations. Now since this term is already subjected, easily what I'm going to do is z is minus y. I'm going to use that here. See, look at the board. From 1 I can write minus 3 equals minus 2y plus z, but z is minus y. Then plus z is minus y. Simplify this. Minus 3 equals minus 2y minus y, which means minus 3 equals minus 3y, y equals 1. Y equals 1. Y equals 1 kila now. Y equals 1. If y equals 1, you can determine z from 1 here again. Now if z is needed, say z is minus y, which means z equals minus 1. So final answers, x equals 1, y equals 1, z equals minus 1. So I didn't see any one of you got these 3. What was the reason, ma'am? Simultaneous equations are by one. Huh? Were you scared with were you scared with simultaneous equations? Right? Simultaneous equations. Equations දෙකක් තිබ්බනම් ඒ දෙක merge කරලා simplify කරන්න. Okay, take it down if there are any corrections to be made. You can take down if there's anything to be corrected. Right? Is it understood now? Is it understood now? Tell me. Understood? කොහොමාරි simplify කරලා මේ terms ටික හොයාගන්න ඕනේ. Right? Sometimes you will get direct answers, sometimes not. Now here you don't have direct answers, then you have to simplify them as simultaneous equations and get answers. Somehow you need to determine these unknown indices. Yes, okay, good. Right? So there was a small difference here with the simplification. Simplification එකේ පොඩි difference එකක් තියෙනවා. Means you have to go with simultaneous equations like this. Right? And when you have simultaneous equations, when you have got simultaneous equations, you have to decide whether you are going to add terms or substitute. Sometimes substitution and plug in, sometimes adding to cancel some terms, sometimes you have to subtract to cancel terms. So likewise, you know how you are determining simultaneous equations now. So likewise, you have to deal with it, right? Or else simultaneous equations simplify කරන්න. Like when you have මේ වගේ equations, x minus 2y equals 5 and 3x minus y equals 8, right? මේ එකක් තිබ්බොත් simplify කරන්න ඕනේ. Same thing. Now if you need to make coefficients same, you have to multiply and make coefficients same, and you can add or subtract to cut them off. So likewise, all the O-level simplifications are applicable here, are applied here. Okay, let's go to the third one. So can you explain it again, that m to the power 0? Zeroth power of any number is 1. Zeroth power of any number is 1. Now here the idea is like only LT minus 2 was given. Only LT minus 2 was given, right? Which means this is like 1 times LT minus 2, right? 1 කියන්නේ m to the power 0. m to the power 0 LT minus 2. So therefore, if there is no such term in that side, which means its zeroth power is there, because zeroth power of any number is 1. Zeroth power of any number is 1. Now m to the power 0 is 1. Then 1 times LT again, that LT comes. Right? Zeroth power of any number is 1. Understood? Zeroth power of any number is 1. Okay, 3. L squared t minus 1. I'll mention the question here. L squared t minus 1. L squared t minus 1 equals ml t minus 2. ml t minus 2 to the power x. LT minus 1. LT minus 1. And LT minus 1 to the power y. And then t to the power z. And then t to the power z. Okay, this is the sum. Now listen first. Listen. Now there's a difference here. There's a small difference here again. There's a small difference here again. What's the difference? Now here, L terms, T terms, M terms are, they are spread everywhere. They are spread. They are not isolated, right? So therefore, as the first step, what you can do is you can simplify this further and isolate MLT, right? Which means take all M terms together and take all L terms together with a common index and take all T terms together with a common index, and then only you can do this, right? මෙහෙම තියාගෙන බෑ මේ. L is here, and T is at three places, here, and here. So therefore, simplify these brackets and isolate MLT. Isolate MLT. And once you got this kind of an equation, like by isolating MLT with their common index, isolated terms with the common index, and then start the dimension analysis like this, right? So මේක මෙහෙම තියාගෙන කරන්න බෑ. මේක simplify කරලා isolate කරගෙන හදා ගන්න ඕනේ. හදාගෙන කරන්න පුළුවන්. Right? Right? If you have already tried, drop me the answers, send me the answers. Any answers? Yeah. X equals 0, y equals 2, z equals 1. Okay, one says x equals 0, y equals 2, z equals 1. What about others? What about others? Try it, try it. Others? What are the answers? So only one got answer set. Only one got answer set. Right? Right? මම කියවනේ මේක simplify කරලා මේ විදිහට isolate කරලා මුලින් equation එක හදාගන්න. හදාගෙන ඉවර වෙලා මේ වගේ dimension analysis එක කරා නම් හොයාගන්න පුළුවන්. Right? X equals 0, y equals 2, z equals 1. That is same as the previous set of answers. Yeah, then it might be correct there. Okay, I'll erase this. Right, now I'm also going to start. So if you can get these final values before I start the discussion, right? That's very good. Okay, time is enough. I'll also start. See, now first I'm going to simplify this. First I need to simplify this. This is my simplification. L squared t minus 1. And in right hand side, this bracket can be simplified. M to the power x, L to the power x, t to the power minus 2x. Right? And from the second bracket, L to the power y comes, t to the power minus y comes. And this is t to the power z. So you know these simplifications. If you have x to the power a to the power b, right? This can be written as x to the power ab. That is the idea, right? Minus 2x, so likewise. And if you have something like this, let's say ABC to the power 2 again, this can be written as a squared, b squared, c squared. The power is applicable separately for the multiplication, right? Use index simplifications, simple index simplifications, right? Now going to isolate them. Now this is L squared t minus 1. And only one m term is here, then m to the power x, right? Then L. There are few L terms. One L is here and here. That's all. Two L terms, right? So which means this can be written as L to the power x plus y at once. This can be written as L to the power x plus y at once, right? Because you know this way, 2 to the power 2 times 2 to the power 3 can be written as 2 to the power 5. Index simplifications. 2 to the power 3 times 2 to the power 2 times 2 to the power 3 can be written as 2 to the power 5. Index simplifications. I use the same thing here. And then for t also, see, here we have 1t, here 1t, here also 1t, right? So I'm going to isolate them. Then for t, from here minus 2x and from here minus y plus z. So this should be the final equation, right? So once you got this equation, now you can start your dimensional analysis. Once you got the equation, you can start dimensional analysis, right? Okay. Now similar to the previous case, this is m to the power 0, m to the power 0. Then if I go to m, left hand side, that is 0, which means x equals 0, right? So if there's no m term here, means that is actually m to the power 0. That is actually m to the power 0. Right. Then since x is known, determining L will be determining y using L will be easy. Right. Then L as the second thing. Left hand side 2, right hand side x plus y. x is 0, which means 2 equals 0 plus y, right? Which means y equals 2. Y equals 2, right? And for z, we have to go with t. We have to go with t in left hand side minus 1 and right hand side minus 2x minus y plus z. Then minus 1 equals minus 2x, x is 0. So this becomes 0. Minus y minus 2 plus z. Simplify this. Z equals 2 minus 1 can 1. Right? So final answers are x equals 0, y equals 2 and z equals 1. Yeah. Your answers were correct. Yeah. The ones who put your answers in chat box, they were correct. Very good. Good. So likewise, engage with this. Right? Very good. All right. Take it down if there are any corrections to be made. And these are the simple simplifying techniques I used. Right. Okay. Now it's time to ask your questions if you have any questions. Right. Or if it is clear enough up to here, up to this point, if that is clear enough, so at least put a thumbs up or say me it's clear. Right. Both of you on Zoom and YouTube. Tell me. What about it up to this point? Clear. 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 All right. Clear. Right. Okay. Now let's see a complete dimensional analysis. See, look at the board. Look at the board. Look at the board. Now I told you, dimensional analysis is a technique we have to get the correct relationship of terms. We need to get the correct relationship among terms. Right? Dimensional analysis is to get the correct relationship among terms. Right? Now we will start with an example question, and using that example question, I will describe everything. Right? Take this down. This is not in the tute. Take this down. This question is not in the tute. So take this down. Write down this as a question. Write this down as a question. Write down. Write down. Pressure. Pressure. Write down. Pressure within brackets capital P. Pressure within brackets capital P depends on depends on perpendicular force, depends on perpendicular force within brackets capital F, depends on perpendicular force within brackets capital F, and area capital A, and area capital A, and area capital A. Right? If proportionate constant, if proportionate constant, if proportionate constant if proportionate constant within brackets k equals 1, if proportionate constant k equals 1 in above equation, if proportionate constant k equals 1 in above equation, derive the correct relationship among 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 above physical quantities. Derive the correct relationship among above physical quantities. Derive the correct relationship among above physical quantities. Okay, so I hope every one of you took it down. Okay, now listen, I'll explain this question from zero, from the very scratch, and after this explanation, 100% idea about the dimension analysis, how the dimension analysis is building up and how the final equation is derived. That idea will be clear after this single explanation. Right. Now stop all your work and look at the board. Stop all your work and look at the board. See. See. Stop all your work and look at the board. See. Now, when this description is given, first you have to go through the description and identify the dependent variables and independent variables. What are dependent variables and independent variables? Right. What are them? Oral salat mega dannawa, but sometimes you might know them as independent and dependent variables. You might not know them as independent and dependent variables. Now, when we write an equation like, let's say y equals 2x minus 5, y equals 2x minus 5, x is called the independent variable. X is called independent, and y is called dependent. Y is called dependent because whatever the value we put for x, whatever the value we put for x will be calculated as the value of y, right? Now, as an example, if x equals 0, y is minus 5. If x equals 1, y is minus 3. So, likewise, x is independent. When x changes, y changes accordingly. When x changes, y changes accordingly. So, therefore, this independent variable means that's a free variable. Extra ඕන value එකක් ගන්න පුළුවන්. But with x, y changes with respect to x, right? So, therefore, y is depending on the value of x. So, that is called the dependent variable, right? මෙන්න මේක තමයි independent and dependent variables කියලා කියන්නේ. Now, from here also, you have to identify the independent and dependent variables, right? Now, in the description, it is clearly given that pressure depends on, right? So, by words also, that is very much straightforward now, by words itself, right? I gave you the pressure P depends on, which means pressure is going to be my what? Dependent variable, because pressure depends on these two. Pressure is going to be my dependent variable, and these two are going to be my independent variables. Is that idea clear? Is that idea clear? So, therefore, pressure is going to be my dependent variable, and both of them going to be independent. Is that clear? Right. Now, first step is this. Right. See, first step is this. First step is this. Look at the board. Now, knowing these independent and dependent variables, now we have to identify their relationships like this. And we don't know yet. Now, even though pressure depends on force and area, we don't know to which power of force or to which power of area it depends on. That we don't know, right? So, therefore, this is how we take this down. Look at here. Dependent variable is P. Look at here. This is the first step. This is the first step, right? Step 1. Dependent variable is P, and P depends on. Now, we don't know whether it's equal yet. Depends, right? To show dependency, we are using proportionate signs. This is called proportional sign. No, proportionate sign. Proportional sign, right? To show that it depends. P proportional to F ne? F. But we don't know to which power of X. So therefore, we are going to consider this as F to the power X. Let's say F to the power X. Right? And then again, P depends on area, but again, we don't know to which power of area it depends. P depends. So therefore, let's consider that as Y. This is my initiation. Right? From the description, I know it depends for sure. It depends, but you don't know to which power. F squared depend on F minus 1, we don't know. Therefore, we have to consider these powers as X and Y. And through a dimensional analysis, we are going to determine this X and Y and get the final equation. That's the whole idea we are going to do here. Right? Now, this is the first step. This is the first step. I'll separate these steps for your identification. Listen. I'll separate these steps for your ease of reference and for your ease of identification. Otherwise, when you do this in an exam, you don't need to separate steps. Mamme separators gahala wada steps ika venkalla pennanna. So you to identify the steps. Otherwise, that is not a must to do in your work in an exam. And this is actually an essay question type. Make essay type pack. MCQs are also coming sometimes, but essays are coming most importantly. So which means you have to know all these steps because you are practicing for an essay question here. Right? Look at here. This is the first step. And the second step is, this is the first step. First step. And the second step is, if I have multiple dependents in the sense, these two, if we have multiple dependents, if you have multiple proportionals, to the multiplier of those proportionals also, that same dependent variable is proportional, right? As an example, now in maths we can write something like this. If k proportional to A and if k proportional to B, we can write k proportional to AB. We can write k proportional to AB. Now we are going to use that same idea here, right? Which means this P is proportional to the multiplier of these two as well, f to the power x, a to the power y. This is the second step, right? And then as the third step, what we do is, now we don't have an equation yet. This is not an equation. This is just a proportional equation, not an equation. This is a proportionality. So therefore, to make this an equation, we can use a proportionate constant, right? Something like this. If I have, let's say, now from here, k equals AB. Now as a proportionate constant, if I use, let's say, capital A, this is called the proportionate constant. Always, I know in O levels also you have this idea, but if that is forgotten from your heads now, I'm recalling again. If you have a proportional equation, if we use an equal sign with the proportionate constant, it can be written as an equation. So we are going to use the same thing again. And I'll be considering the proportionate constant as k. I'll be considering the proportionate constant here as k, right? And this can be written as P equals k times f to the power x, a to the power y. K times x to the power x, f to the power x, a to the power y. Right? This is step 3. And next step is now we are going to substitute dimensions. Look at here. Here is we are substituting dimensions. We know dimensions of pressure will be dimensions of k times dimensions of f to the power x times dimensions of a to the power y. Now we are going to substitute dimensions. And about k, I have given you a hint. About k, I gave you a hint. K is 1 and k equals 1 in that particular scenario. In that particular equation, k equals 1. 1 is a number. If 1 is a number, numbers are dimensionless. Right? 1 is a number and numbers are dimensionless. Right? Then plug dimensions. Dimensions of pressure will be what? ml minus 1, T minus 2. dimensions of pressure, ml minus 1, T minus 2. And since K is a number, no dimensions, so we can write it as 1. We can write it as 1. F is a force. Dimensions of force is mlt minus 2. Whole thing to the power x. And dimensions of area. Area is length into width. So dimensions of area is L squared. Whole thing into y. So likewise, you have to substitute these dimensions. You have to substitute these dimensions. Right? Once dimensions are substituted, next step is we are going to simplify this. Then me equation kara kaling api simplify karwa equation ek again. Now this equation is like the equations that we practice simplifying before. Right? So that's why I wanted you to practice it. Right? Now it is like that now. Now you can simplify this and isolate terms. Look at here. You can simplify and isolate terms. Now this is like hereafter simplification. Na? ml minus 1 t minus 2 equals 1 times anything is 1. Then this is m to the power x, l to the power x, and here t to the power minus 2x. And from this bracket, l to the power 2y comes. Isolate them, which means ml minus 1 t minus 2 equals only 1 m is here, that is to the power x, and there are 2l terms, it should be x plus 2y, and only 1 t term minus 2x. So you have to come up to this point after the simplification. That is called the simplification and isolation of terms. This is called the simplification and isolation of terms. Right? Now, hereafter, now it is very easy. What you can do is, now you can start dimensional analysis. And if you do the same thing that you practiced before for MLT using dimensional analysis, now you can determine x, y, x and y. Here only two terms, x and y. If x and y are known, then we are going to plug it here. This is the equation. You are going to plug it here and get the correct relationship. Right. Now, before that, now here, we will start the simplification. First tell me, is it clear up to this point? Tell me, is it all clear about the first 4 steps up to this point? Is it clear up to this point? Quickly, tell me. Clear. And if you got any doubts, please ask. Yes. Can you explain step 4 again? Step 4. Okay. Step 4. Step 4 is substituting dimensions. Step 4 is substituting dimensions. Right? Dimensions of P should be dimensions of K times dimensions of F to the power X times. Make an equation here. Dimensions of A to the power Y. Right? Dimensions of P is, it's a proved dimension. Right? We proved this in the last class, ml minus 1, t minus 2. And K is a number because I gave K as 1. Since K is a number, K is dimensionless. Right? Dimensionless scenarios are considered as 1. Right? Now, in today's class also, when I was discussing the homework questions, I told you there are 5 dimensionless occasions. Right? Numbers are one of the dimensionless occasion. Always we can consider dimensionless occasion as 1. Dimensionless quantity ka tinna ya 1 කියලා අපිට calculation එක consider කරන්න පුළුවන්. Right? For calculating purpose, always we can consider a dimensionless quantity as 1. ඒක තමයි මෙතන 1 කියලා දැක්කේ. Otherwise this doesn't mean k equals 1. The idea of this 1 is this is dimensionless. Idea of this 1 is this being dimensionless. Idea of that is this being dimensionless. And this is dimensions of force. That is a proved dimension. We proved the last day. ml t minus 2 to the power x. So whole thing to the power x. Right? Then A, an area, dimension of area is L squared, and that whole thing to the power y. Once you have written this, then simplify these brackets. This is a bracket simplification. If the brackets are simplified, you can isolate terms like this. Right? Isolate terms. So as we did in the previous example practice question. Isolate terms. And this is the final equation with isolated terms MLT. Okay, what about now? Why do we use K if it becomes 1 anyway? Oh. That is one. Listen, that's a good question. Listen, that's a good question. That's a good question. Listen, k equals 1 in this given question. K equals 1 in this given question. K can be any value and k will be given to you. So therefore, what we do is we consider it as k and finally we are going to substitute k. May question එක විතරයි k කියන්නේ 1 නා. K can be any value. Now if you are given as k is let's say 5 or 5 over 8, sometimes k will be given as let's say 3 over 4. K is given as 5 over 17. So likewise, with that k changes. So therefore, what we do is we will keep doing with k and finally we will be substituting k. So that's why I use k. Clear? Is it clear? Clear? Right. Now, start from here, start from first step and write up to this. Start from first step and come up to here and then simplify x and y. That is something you know already. And then simplify x and y. And tell me what x and y are after the simplification. Tell me what x and y are after the simplification. Yeah. Tell me x and y. Was finished. Yeah. What are the answers? X equals 1, y equals -1. Good. Others? Have you all got that? Now, what about these ones on YouTube? You also can send your answers, right? The ones on YouTube, you also can send your answers to the live chat so I can see it, right? Others? Mega hurry. Simple simplification. This is a very simple simplification compared to what we practiced before. Right? Mega tagga simplify x I gun. Yeah, what are x and y? What are x and y? Is it same? One says x equals 1 and y equals minus 1. Yeah, one says x equals 1 and y equals minus 1. Yeah. Okay. Right. Okay. Let's see. Let's see. Now this is my simplification. Now hereafter, first I can go to m. Right? M is very straightforward because only one m term is here. This is the dimension analysis of m. Right? मैं notation का mention करना होने, and I didn't mention you about that before. This is the notation for dimensional analysis. Huh? This is the notation of dimensional analysis. No need to write anything in words. Just mention this notation. The idea is you are analyzing dimensions of capital M. Right? Idea is considering dimensional analysis for M. That's the idea. Right? Then left hand side 1, right hand side x. So which means x equals 1, very straightforward. Right? And for L, if I do this for L, left hand side we have minus 1. Right hand side we have x plus 2y. X plus 2y. Right? Then minus 1 equals x is 1. X is 1 plus 2y. Take this to the other side. Minus 2 equals 2y. Which means y equals minus 1. Correct. Right? So these two are the answers. Yeah, these two are the answers. X equals 1 and y equals minus 1. Right. Clear? Okay. Now x and y are known. Now x and y are known. And hereafter, what we do is, since x and y are known, we are going to plug these two values in our equation. Because my final target is deriving the final equation. Now I'm going to derive the correct relationship among them. Correct relationship means that is an equation. Right? Correct relationship again, that is an equation. So that is all about an equation. Right? So therefore, now I'm going to take this equation now. Label this equation as 1. Here. Here. Label this equation as 1. Then we can mention that as, see, from 1. Now after this is the last step. Step 5. This is the last step. And we can mention this as from 1. Equation is P equals K f to the power x a to the power y. Now plug these values. And as a practice, once you got all final answers, if you can mention like this at a single place, that is better, because for the marker it will be easy to see. So therefore, in a single place, as a practice, mention these values like this. Right? And then plug them. P equals now k times f to the power x. X is 1. A to the power y is minus 1. And we know k equals 1. Since k equals 1. This is given, na? This is a given data. K equals 1. This is a given data. That is a given data. Right? So which means P equals 1 times f to the power 1 means f ne. Right? And a to the power minus 1 can be written as 1 over a ne. Right? A to the power minus 1 can be written as 1 over a. So final answer, P equals 1 times f is f over a. Final answer, P equals f over a. Right? Now in an equation, usually we don't keep minus integers. Right? In an equation, usually we don't keep minus integers. If you have minus integers, put them in the denominator and make it positive. Put them to the denominator and you can make it positive. Right? And final answer, P equals f over a. And for this first example, first calculation, I used a known equation to show you how we can arrive at this equation using dimensional analysis. This is the general equation of pressure. මේ තියෙන්නේ pressure එකේ general equation එක. Right? මේක ඔයා දන්න equation එකක්. Pressure එකේ general equation එක මේ. Pressure is perpendicular force over area. Right? But without knowing that equation, we proved that equation through dimensional analysis. So that's the whole purpose behind dimensional analysis. We don't need to know the equation, but if we know the dependencies like this with the proportionate signs, proportionate constants, right? With the proportionate constants, we can derive the final equation. That's the ultimate goal of doing dimensional analysis, right? හරියට අපිට equation එක හොයාගන්න පුළුවන්. The correct relationship, which means that's the exact equation. So final equation is this, P equals F over A. Okay. Tell me if you understood this or not. Tell me if you understood this or not. If it is not clear, that's totally fine. Totally fine. Ask me anything and get it clarified. If it's clear, say it's clear. If you understood, say understood. If you got it, say you got it. Yeah. Everyone? Zoom, YouTube, everyone? Yes. Clear. Got it. Right. Okay. Okay, good. Very good. Okay, very good. Right. So simple as that. This is a simple thing. If you know these fundamental concepts properly, if you know these fundamental concept properly, right? Dimensional analysis is not going to be a difficult question, right? This is a very much doable question, right? So even though this is the most complex part in dimensions, right? Once you understood these fundamentals, this is very much easy. Very easy, very easy, very easy, right? So finish it up to here. Finish it first. Finish it. And meanwhile, you can ask if there are any questions, if there's anything to get clarified from my end. Okay, finished? Right? Simple idea එකක් තියෙන්නේ. මේ fundamental concepts එක හරියට දන්නවා නම්, fundamental concepts එක clear නම්, ටක් ගාලා මේ වැඩේ කරන්න පුළුවන්. Right? Fundamentals ටික හරියට දන්නේ නැතුනම තමයි ඉතින් stuck වුණොත් stuck වෙන්නේ. Fundamentals you have to know. Right? If your fundamental knowledge is thorough, if your fundamental knowledge is solid, definitely this is very much doable. Very much doable. Okay, done, right? Okay, now let's try few more questions. Okay, again, any question before moving on from this? Right? Any question before moving on from this? Many steps essential now. Since you are getting an essay question from this, listen. Since you are getting an essay question from this, right? If you got the essay, mentioning all these steps in this same order is essential, right? Don't ignore, don't skip any steps here. These are the essential steps, right? Steps එක පොඩ්ඩක් මතක තියාගන්න. You have to keep them in mind, like the flow, dependence, and then the writing the multiplication of dependence, then introducing proportionate constant and considering dimensions and simplifying and dimensional analysis and the final equation. Simple as that. Okay. Once again, any other question before moving on? Any other questions before moving on? What do you say? Any other questions before moving on? All good? Is it all good? All good? Harda, is it all good? Good, ne? Right. Okay, let's move on. Let's move on. Right. Okay, right. Go to question 5 in the tube. In the tube, page number 4, question 5. Go to page number 4, question 5 in the tube. Page number 4, question 5. Okay, page number 4, question 5, part 1. Tube, page 4, right? Question number 5, part 1, start. And it says viscous force on a sphere F. Viscous force on a sphere F, capital F, depends on followings. Dependents are given. Coefficient of viscosity, radius of sphere, velocity of sphere, right? Since you don't know about coefficient of viscosity, that is called eta, I will give you the dimensions of eta. Look at here. Look at here. I will give you this dimension of eta as a given data. Consider this as a given data. Look at here. Consider this as a given data. This is called eta. This is a Greek symbol. This is called eta. This is called eta. Right? Dimensions of eta is given. Consider this as given. Right? So I'm giving this to you. This is ml minus 1, t minus 1. Dimensions of eta is ml minus 1, t minus 1. Right? That is called eta. That is not n, not n. That is eta. Consider this also as a given data. And start now. Start now. I'll give you like 5 minutes before I start. Start now. If proportionate constant comes in the equation, does not have dimensions, and value is 6,5. Can you see? Can you see? That's what I told you. A can be any value that will be given to you, right? So that's why we don't use that value from the beginning. We just write it as k, and finally we'll be substituting that value, right? Now k is 6,5, right? Equation එක දීලා තියෙනවා. Prove f equals 6,5 eta rv. Prove f equals 6,5 eta rv, which means now if you do the dimension analysis part properly, if you conduct your dimension analysis properly, you should get that as f equals 6,5 eta rv, right? Okay. See, start. Now, what is the dependent variable? What is the dependent variable? Dependent variable is viscous force. Dependent variable is viscous force. So there are few dependents as viscous force depends on coefficient of viscosity, eta to the power x, let's say. And again, viscous force depends on radius of sphere, r to the power y, let's say. And again, viscous force depends on velocity of sphere, v to the power z, let's say. So these are the dependents. These are the dependents. So likewise, you can identify the dependents and start your working. Identify the dependents like this and start your working. Right. And tell me the answers of x, y, z. Tell me the answers of x, y, z after your dimension analysis. And having that answers, uh, the given equation should be proved because it is given. So is k considered as x, y? Yeah, it's given now. It's given. It is given. Proportionate constant k, right? For proportionate constant, we use k as a symbol. That's a constant, so that's why. Now in this case, it is given as proportionate constant equals 6, 5, right? So in this case, this is given that k equals 6, 5. That is a given data. This is a given data. Given. Okay, start. Right. Yeah, right. And if you finished and if you got the correct answer, correct equation, uh, just put to the chat that you got the answer and you finished. You are finished. Right, right. Okay, anyone finished? Anyone has finished? Not yet. Now, if you have any questions or anything to clarify, feel free to ask. Feel free to ask, because as I told you, now from today, dimension analysis will be finished. It will be completed, right? From today, after today, dimension analysis will be completed. And next week, we are moving to measuring instruments. We are moving to measuring instruments. One of the most crucial parts, right? Most crucial parts in Unit 1, measuring instruments. Share the message. Share the message if there are any friends, any colleagues of you who wish to join, who are willing to join, because if they are fresh to joining, joining from measuring instruments is kind of a milestone point, because for measuring instruments, there is no any link with the previous units and dimension parts we discussed. So they can start from measuring instruments and move on. Then while moving on, they can cover the first 3 days. That's true, but can start from measuring instruments without any hassle. What's the dimension for radius? Radius is a, that you have to think. We have only 3 dimensions: mass, length, and time. Right? Radius is a length. Radius can length. Radius is a length. So the dimension of radius is L. Radius is a length. Right? Okay. So this is the plan for next day. This will be the plan for next day. We are starting measuring instruments. Measuring instruments. Measuring instruments. And we have 4 major instruments, and with meter ruler, there are 5 altogether. Right? Meter ruler, again, that's a very simple instrument. So with the meter ruler, there will be 5. Meter ruler, then vernier caliper, and then micrometer screw gauge, then sperometer, and traveling microscope. So these are the 5 measuring instruments you are going to have in your A levels. These are the 5 measuring instruments you are going to have in your A levels as measuring instruments, right? And first day we will be starting with, this is a very small part. First day we will be starting with the meter ruler, and then vernier caliper, right? First day. And in the coming days during the month, right? In the coming days during the month of August, we'll be covering all measuring instruments, right? We'll be covering all measuring instruments, and as I told you, for all demonstrations, I'll be using the real instrument, right? Real instrument. So therefore, yes, unlike you are seeing a video, an image, unlike you are seeing an image, not a video, unlike you are seeing an image, you will see the actual instrument and how it works, how the movements are, how we are taking a measurement and everything. I'll be showing to you, right? So don't miss a class, because that's a milestone lesson you have in your syllabus, measuring instruments. And from measuring instruments, one MCQ is coming and another structured essay question is coming. One MCQ means 1 mark and one structured essay means 20 marks and 5 marks out of 100. 20 out of 200 and 5 out of 100 because 200 paper is taken down to 50. What is 5 marks? Then altogether, as a collective mark, around 6 marks. Around 6 marks from 100 out of 100 is there with measuring instruments. 6 marks, that's a considerable amount. That's a very considerable amount. 6 marks. Right? So don't miss the class. Okay, let's see. I'll start this. Let's see. Okay, now, yeah, some of you have got answers, and I think most of you have got. Yes. See. Okay. Okay. Then f is proportional to the multiplier e to the power x, r to the power y, v to the power z. Then make this the equation. Convert this to the equation. I'll be using the proportionate constant as k. Then k times eta to the power x, r to the power y, v to the power z. Since we need to use this equation again, I'll be labeling this equation as equation 1. I'll be labeling the equation as equation 1. Right? So hereafter, you can substitute dimensions. Hereafter, you can substitute dimensions. Substitute the dimensions. See? Then dimensions of f will be dimensions of k times dimensions of eta to the power x, dimensions of r to the power y, dimensions of v to the power z. Right? Then I'll be writing the next line here. Substitute them. Dimensions of force mlt minus 2. Dimensions of k. K is dimensionless. It is given in the question. That's a given data. K is dimensionless. So that is 1. Eta, I gave you eta. ml minus 1, t minus 1. Whole thing to the power x. R is a radius. Dimension of radius is L because radius is a length. L to the power y. Then V, velocity, dimension is LT minus 1, whole thing to the power Z. Simplify this. Simplify this. Then MLT minus 2 equals here M to the power x, L to the power minus x, T to the power minus x, L to the power y. And here L to the power Z, T to the power minus Z. Right. Isolate terms. Isolate MLT. Only one M is here, which means M to the power x. And L, there are few L's here, minus x plus y plus z. Right? Minus x plus y plus z. This is minus x plus y plus z. And then T minus x minus z. Right? So you can check your equation whether it's correct. This is the final equation you have. This should be the final equation you have. Right? That should be the final equation you have. Clear? So you can check your steps. Now, even though you have got the answer, check steps. Right. Then, now you can start your dimensional analysis. Now we can start dimensional analysis. Dimensional analysis for M. Dimensional analysis for M. In left hand side, I have 1. Right hand side, only x, which means x equals 1. Very straightforward, x equals 1. Right? Very straightforward, x equals 1. Then L. See, now I'm going to do something like this. Listen. Now you have to observe equations. You have to observe equations before writing. Now, if I do L, if I do dimensional analysis for L as a second step, even though x is known, y is unknown. Y and z both are unknown, which means we can't determine anything. Y and z both are unknown. But if I go to t, x and z are there, and x is known, which means z is determinable. So therefore, without doing, I mean before doing dimension analysis for L, I'm going to do the dimension analysis for T as the second dimensional analysis. So likewise, observe them and you can do in that the order that you can find answers easily, right? So otherwise, sometimes if you get simultaneous equations, there is no option other than simplifying simultaneous equations. But in this kind of a case, there are no simultaneous equations. So you can do do T, the third dimensional analysis at the second T at the second one as a second stage and get it. So likewise, observe. Nikang practice again makarannat epa, like there is no order. I told you, there's no order like MLT, right? So whatever you can get first, get it first. Whatever you can get it second, get second, get it second. So likewise, that you decide, right? That you decide. Otherwise, don't be like machines. Don't be like robots and machines and do it like MLT always. No, there's nothing like that. That's observe the equations and think and do something, right? Then for T, left hand side minus 2, right hand side minus 6 minus z, right? So minus 2 equals minus x square minus 1 minus z. Simplify this, z will be, take z to this side and 2 to the other side. Z is 2 minus 1, which means z equals 1. Z equals 1. Z equals 1. Then now we can do L. Now we can take care of L. Since both x and z are known, right? L. In left hand side I have only 1. Right hand side minus x plus y plus z. Minus x plus y plus z. Then substitute these values. X again 1, so minus 1 plus y is what we need, plus z is plus 1. Now you can see minus 1 to plus 1 cancels, so y remains 1 equals y, which means y equals 1. So I told you, once you got all three answers, as a habit, mention all three answers together. X equals 1, y equals 1, z equals 1. So these are the final answers. X equals 1, y equals 1, z equals 1. Right. Now from dimension analysis, we are one step away. Now we have to prove the equation from this. Now we have to prove the equation. Right. Then from 1, now you can go to the equation. You can go to the proof of the equation. From 1, f equals k times e to the power x. X is 1 now. R to the power y. Y is also 1. V to the power z. Z is also 1. And we know k equals 6, 5. So final answer, f equals 6, 5 eta r v. F equals 6, 5 eta r v. So likewise, you can get that given answer through the dimensional analysis. So this is the beauty of dimensional analysis. This is the purpose of dimensional analysis. Right. Any questions on this? Tell me quickly. Any questions on this? Any questions on this? Or is it clear enough? All clear? Tell me. So before moving on to the next one, quickly. Any questions? Fine, sleep either. Now it's 9:35 now. Yet. Right? Quickly. Okay, good. Others? Others? Clear. 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 Right. Very good. Very good. Okay. All right. Good. Very good. All right. Very good. Very good. Okay. Let's do another one. Let's do another one. Next one. Part two. Part two in five. Part two in five. Huh? Question five. Part two. Rate of volume flow through horizontal tube. V over T depends on followings. Rate of volume flow. Right? Volume. Volume over time. Rate of volume flow. Anything over time is a rate. Anything over time is called a rate. Right? Velocity, change of velocity over time is rate of change of velocity. Change of displacement over time is change of rate of displacement. Now this is rate of volume flow. So V is not a velocity, V is a volume. Right? Gradient of pressure delta P over L. Right? Delta P is pressure difference. Delta can change. Delta can change. So that is change of pressure over L. And L is not given. It should be given. L. Introduce that is missing. Okay. See, introduce L, and you can consider that as given. L is given actually. Yeah. L is length of tube. Introduce L as length of tube. Introduce L as length of tube. Right. Coefficient of viscosity same. So here I gave you the dimensions of coefficient of viscosity and radius of tube. Radius of not no. Radius of tube. That's another small typing mistake. It should be radius of tube. Radius of should be radius of tube. Right. So these are given. These are given. Length is L is length of tube. And eta is given. Dimensions of eta I gave you before as well. That is ml minus 1, t minus 1 as before. Right. That is ml minus 1, t minus 1. Both are given. ml minus 1, t minus 1. Okay, start now. Start now. Proportionate constant equals 5/8, which means k is 5/8. Given. K is given. K is given as 5/8. K is 5/8. Derive the correct equation among above physical quantities. Derive the correct equation among above physical quantities, right? Is there a difference between the coefficient of viscosity and viscosity itself? No. Same. Same. Okay, start now. Start now. So it clearly says volume flow rate depends on followings, which means now the dependent variable is going to be V over T. Right? Dependent variable is going to be V over T. Dependent variable is V over T. And this V over T is proportional to, I'll go with the given order, gradient of pressure, delta P over L. But we don't know to which power of delta P over L. Let's say X. Right? Let's say X. And again V over T proportional to coefficient of viscosity eta, but we don't know to which power, let's say Y. And then V over T proportional to radius of tube R, again we don't know to which power, let's say Z. So these are the dependents. These are the dependents. These are the dependents. And if there's anyone who has finished now, so you can send your answers. You can send your answers if you have finished. Right? If there's anyone who has finished, you can send your answers. Send your answers if you are done. Anyone with answers? Protect. Right, right. Now we are at the very last part. We are at the very last parts of dimension analysis, right? So try these questions by your own and make yourself comfortable with the lesson. So that's the final target, final goal of this, right? Now, if you are comfortable with these questions, then keep trying few more questions, keep trying few more questions, and make yourself comfortable. Right? That's the ultimate goal. Now, even if you got the lesson today, even if you got the lesson today, even if you understood the lesson today to the fullest, but if you didn't work for, if you didn't recall these things for like 2 weeks, 3 weeks, again these things will be forgotten. That's the human nature. That's the human nature. So that's why we have to do them regularly. That's why I asked you to do work in a weekly basis, right? So weekly, recall them because always your workload is going to be increasing when you are learning these three subjects, all three subjects for 3 years coming up, for 2.5 years coming up, right? It's going to be always an increasing workload. So week by week, day by day, what you know, your knowledge increases, your knowledge enhances, which means the workload enhances, workload increases, right? So therefore, do it weekly. If you understood the lesson today, now you have to keep it like that. To keep it, we have to practice these questions regularly, right? So that's how it is. Now, even though you are learning dimensions, units and dimensions, dimension analysis today, right? The question is going to be coming in 27 A levels. That's the final target. Final target is in 27 A levels. Now, by that time, if you can't remember this, then that will be a problem. That will be a problem. So that's why Always you have to have the continuous practice, right? So don't let this forget from your head. That's the idea. Don't let this forget from your head. Any answers? X equals 2, y equals minus 2, z equals 3. No. Check again. Check again. All three values are different. All three values are different. Since all three are connected, now if you have done any mistake in a single value, the other two will also be wrong. That's why now your all three values are different. Check again. What about others? Be mindful with your simplifications, because if you made a simplification mistake, uh, there is no point of knowing this. Again, even if you know everything, even if you know everything about dimension analysis, but yet if you made a simplification mistake, you will end up having wrong answers, right? So therefore, that's a very uh, like worst kind of a scenario. That's a worst kind of a scenario. So be mindful with your simplifications. Others? Are there any others with answers? Send your answers if you got anything. Only one yet. Come on, quick, be quick. Others, what are the answers? Send me your answers. Go quickly. කලින් හොඳට ගණන් හදපු ළමයි හිටියනේ කො දාන්න answers. කලින් ගණන් ටික හොඳට හදපු කට්ටිය හිටියා. Right? So this is again one another equation. This is just another equation. Yeah. What are the answers? Come on. This will be the last question we are discussing from dimension analysis, and this will be the last question for today. And after this question, that will be the end of dimensional analysis. Right? Yeah. What are the answers? Go. Pi over 3. No. No. You have to check again. Sorry. Yeah. Yeah. Sorry. You have to check again. I'll also start. I'll give you like 1 more minute. I'll give you 1 more minute and going to start. Now, if there are other students who have got answers, you can send your answers and uh, check them out. Like make me aware and check them out. Right before I start, I'm going to start in a minute. No one? No one? Why is that difficult? Huh? Is that difficult? What's the problem? Okay, see, I'll also start. Okay, now the product of these three is V over T proportional to delta P over L to the power x, eta to the power y, r to the power z. Right? Then we can make this an equation using the proportionate constant k, then k times delta P over L to the power x, right? Eta to the power y, r to the power z. Right. Hereafter, I'm going to substitute dimensions. Hereafter, substituting dimensions. Then this side, dimensions of V over T. Right? Right side, right hand side, dimensions of K. And this is dimensions of delta P over L to the power x. And this is dimensions of eta to the power y. And this is dimensions of r to the power z. R to the power z. Right? So substitute dimensions. V is a volume. This is a volume flow rate. V is a volume. So volume is L cube. Volume is L cube. Length into width into breadth. So volume is L cube. L cube. Over time, T. K is 1, dimensionless. Right? And delta P. Delta P is change of pressure or difference of pressure. Difference of pressure is also a pressure. Right? Difference of pressure is also a pressure. Difference of pressure again a pressure. Dimensions of pressure is ml minus 1 T minus 2 over length L, length of the tube, length of the tube, L, whole thing to the power x. And eta is ml minus 1 T minus 1 to the power y. And r is a length L to the power z. right? Simplify this. Simplify this. Now I can write the left hand side as L cube T minus 1. L cube T minus 1. And here, this will be simplified. This is L. Once this L is taken to the numerator, this becomes L minus 1. So which means this term is ml minus 2 T minus 2 whole thing to the power x. And this is ml minus 1 T minus 1 to y L to the power z. Simplification, L cube T minus 1 equals, right? This is a simplification now. M to the power x, L to the power minus 2x and T to the power minus 2x. And from here, M to the power y, L to the power minus 1, sorry, minus y, L to the power minus y, L to the power minus y, and T to the power minus y, and here L to the power z. Isolate them. Isolate them. L cube T minus 1 equals M. X and y are there, and x plus y. L minus 2x here and minus y here plus z here, right? And then T minus 2x here minus y here. You can check your equations, you can check your answers whether this is your final equation before you start dimensional analysis. This has to be your final equation before you start dimensional analysis, right? This has to be the final equation. So you can check it. You can check it. And now we are going to start dimensional analysis. Now we are going to start dimensional analysis. Right. Equation dimensional analysis. Right. So if there's no m in this side means, you know this. If there's no m in this side means is m to the power 0. Right? No m means m to the power 0. That's the meaning. That's the idea. Okay, now start your dimensional analysis. First, I'll do with m. Right? This side is 0. Right side x plus y. So which means I have something like x equals minus y. Right? So I'll take this as equation 1 because I can't determine anything yet. We can't determine anything yet. Right? We can just write x equals minus y. We can just write x equals minus y. Right. Next. Then I'll do with t. Because in t also I can see x and y are there. Only x and y. Which means that can be determined after these two equations. So second, I'll go with t. As the second one, I'll go with t. T is minus 1 in left hand side and right hand side minus 2x minus y. Minus 2x minus y. Right. Now from here I know x equals minus y. X equals minus y. So I'm going to use it. See, minus 1 equals minus 2 x. X is minus y. Minus y. Simplify this. Simplify this. Simplify this. Minus 1 equals minus 2 times minus y is plus 2y. 2y minus y. Which means minus 1 equals y. Y equals minus 1. Here I have got one answer y. Here I have got one answer y. Y equals minus 1. Y equals minus 1. Right? Y equals minus 1. Now if y is known, x is very straightforward because x is minus y. From 1. From 1, x equals minus y. X equals minus y. Which means x equals minus y again plus 1. X equals 1. Right. Now both x and y are known. Now I'm going to do with L. Now I'm going to do with L. Dimension analysis for L. left hand side 3, right hand side minus 2x minus y plus z. Minus 2x minus y plus z. Right? Then simplify this. 3 equals minus 2x. X is 1. So minus 2. Minus y. Y is minus 1. Then minus 1 plus z. Simplify this. 3 equals minus 2 plus 1 plus z. And take everything to the other side. Minus 2 plus 1 minus 1. Minus 1 to the other side is plus 1. Which means z equals 4. Z equals 4. Right? Z equals 4. Final answers are, right? Now we have all final answers. Final answers are x equals 1, y equals minus 1, z equals 4. These three are the three final answers. Right? These three are the three final answers. Right? Now, when you have the relationship between index, among index, right? Simplify it. Simplify කරලා තමයි ගන්න තියෙන්නේ. Now, if your simplification is correct, there's no way that the final answer goes wrong. Because definitely it will be correct if your simplification is correct. Right. Now, if that's here, now we can go to the final step. I'll do the final step here. I will do the final step here. What we can say from, where's my equation? Here. From 1. I label this equation as 1. Since 1 and 2 are already labeled, 1 already labeled. Since 1 is already labeled, I'll label this equation as A. Right? You can label with any preferred term to you. So I labeled that equation as A. Then I can say from A. From A. A is my equation now. From A, V over T equals K times delta P over L to the power X. X is 1 now. And eta to the power Y is minus 1 now. And R to the power Z, that is 4 now. Right? And K is given, see, K is 5 over 8. K is 5 over 8. Plug that there. So we'll get the final answer. V over T is 5 over 8 times delta P over L. This is 1 over eta. And this is R to the power 4. So we will mention the final equation like this. See, we will mention the final equation like this. V over T equals 5 delta P R to the power 4 over 8 eta L. Final answer. V over T equals 5 delta P R to the power 4 over 8 eta L. Final answer. Final answer. Right. Is it clear? Any questions? Is it clear? Or any questions? Only one of you got the correct answers. Only one of you got the correct answers, right? Why? Simplification mistake. Probably, yeah, it should be simplification mistakes. Probably. So what if we took y equals minus 6? Same. If your simplification is correct, it will be same. Now, if you took y as minus 6, plug y here. Plug y here, then you will get x as 1. Right? Impact is same. That is same. If you are not getting the same answers, it means that's again a simplification error. Otherwise, that doesn't matter. Whether you consider x as minus yo, y as minus xo, that doesn't matter. We are dealing with equations. That doesn't matter. Yeah. Any other questions? Any other questions? Or is it all clear? Is it all clear? Okay. Okay then. Right. So probably if you have gone wrong, it should be simplification mistakes. If your dimensions are correct, if your dimensions are correct, right? Okay. Yes. Okay. Good. Good. All right. Then listen. Okay. Listen. So then this is the end of dimension analysis, right? So as we planned, now we have finished the full lesson dimension analysis, and this is the end of dimension analysis. And as I told you, next week we will be starting off with measuring instruments. That's a very crucial lesson, a milestone lesson in unit 1. So don't miss the class. Don't miss the class, and share the message, pass the message. If there are any other friends and colleagues, if you have, if they are willing to join, and you can get all updates regarding the class and the times, lessons, everything through my channels and groups, right? So stay connected with them, and you can get all the updates, right? And since this was streamed on YouTube as well, if there's anyone who has missed the lesson for today, you can come to YouTube. I'm not going to remove this from YouTube, right? I'm not going to remove this from YouTube. So that will be there on YouTube. So therefore, if you need to go through the lesson again, or if there's anyone who has missed the lesson, the live class today, so you can just come to the YouTube live, and you can watch it later as well, right? And if you have understood the lesson properly, and if you have got everything properly, once the YouTube video is ended, you can come to that video and put a comment whether you have understood the lesson or not, right? So once the live is ended, otherwise the live chat will be disappeared. So once the live is ended, you can come to the video and you can add a comment there whether the lesson is clear, right? Comment down clear the කියලා whether you understood the entire lesson, right? Video එක ඉවරනට පස්සේ දාන්න. All right. Since there are no any other questions, I'll be winding up the class here. Then we'll be meeting on next Tuesday with measuring instruments, right? So come to the next lesson, come to the next class with the fresh mind, with the fresh head, to learn measuring instruments. And as I told you, we'll be starting off with meter ruler and vernier caliper, right? Okay then. Okay, any other questions before winding up? No? Any other questions before winding up? All good? Anything to know about the things we discussed today, or anything about classes, registrations, hotline numbers, tutes? Tutes will be posted this month onwards. No, right? Tutes will be posted this month onwards, as I told you, right? Now your registration details are collected, right? Now for that address that you have used in your registration, tutes will be posted. Okay, then that's it then for dimension analysis. Okay, you can practice these questions again and again, practice again and again, and make yourself comfortable with the questions. All right then. Okay, then see you all in the next class. Goodbye and good night. Study hard, right? Goodbye. Okay, all of you are welcome. Right, good night.